Assalamualaikum and salam sejahtera. Today I will give lecture on BMCG 3113 Solid Mechanic 2. At the end of this course, the student should be able to evaluate and solve buckling problem of structure members under compressive axial loading. The topic that we will discuss about column eccentric load part 2. The content for this chapter, extension of Euler formula to column with others and condition, eccentric loading, the secant formula. From free body diagram, moment equal to P times deformation minus V. V deflection on the column. This is the differential equation for the deflection curve. Solving by using boundary condition and integration, we get V equal to deformation bracket 1 minus cos bracket square root P over EI times X. Load apply. This is the distance from the centroid of the column. This is the V is the deflection the deflection of the column. The smallest critical load occur when n equal to 1, so that the P critical equal to pi 2 EI over 4 times L power of 2. By comparing the equation Euler buckling, a column with fixed support at its base will carry only 1/4 of the critical load applied to pin supported column. A column with one fixed and one free end will behave the upper half of pin connected column. The critical loading is calculated from Euler formula. P critical equal to pi 2 times E times I divided by L effective power of 2. The L effective for fixed and free equal to 2 times L. Okay, this is the effective length for the type of this column. Effective length. If a column is not supported by pin end, the Euler formula can be also used to determine the critical load. L must be represent the distance between the zero moment point, and the distance is called the effective length or LE. Effective length. Many design could provide column for formula that use dimensionless coefficient K, known as the effective length factor. L effective equal to K times L. The Euler formula can be expressed as P critical equal to pi power of 2 times E times I over K times L power of 2, or the stress critical equal to pi power of 2 times E over bracket KL divided by R bracket power of 2. Column having various type of support. So for pin end, the K value is 1. For fixed and free, the K equal to 2. For fixed end, the K equal to 0.5. And for pin and fixed end, the K value is 0.7. So the various type for every column, you need to memorize the effective length. The actual criterion for load application on column is limited to either specific deflection of column or by allowing the maximum stress in column stress as allowable stress. We apply the load P to column as a short eccentric distance E from the centroid. This is the eccentroid from X section. This is the X section. Then load apply with eccentric distance. This equivalent to apply a load P and moment. So the moment equal to load times eccentric distance. From free body diagram, internal moment in column is moment equal to minus P bracket eccentric distance plus deflection on the column. So the deflection become differentiate equation. Then this is the general solution for differential equation of deflection curve. Then that we apply the boundary condition to determine the constant. The deflection curve is written by this formula. So to determine the maximum deflection due to symmetry loading, both maximum deflection and minimum stress occur on the midpoint of the column. So the x equal to half of L and V equal to Vmax. So the Vmax equals this equation, or Vmax equal to eccentric bracket secant square root P over EI times L over 2 bracket minus 1. The secant formula, maximum stress in column occur when maximum moment occur at the column midpoint. Using equation bending moment and Vmax, so the moment equal to P times eccentric plus Vmax bracket. So the moment become P times E secant square root P times L over 2 EI. The maximum stress in compressive stress max equal to P over A for axial load applied to the column plus moment times C divided by I. I is the centroid for the column. I is the inertia for the column. The stress max equal to P over A plus P times E times C over I secant bracket square root P times L over EI times 2. So the secant formula, if the radius of gradation given, so this is the stress max if the radius of gradation given in the question. So the stress max is maximum elastic stress in column. P is the vertical load applied to the column. E the eccentric of load P measured from the neutral axis of column. The secant formula, C is the distance from the neutral axis to the outer column where the compressive stress occur. A equal to X section area of column. L is the length of the column. E the modulus of elasticity. R equal to radius of gyration. Thank you.